Welcome back, everybody. Welcome back to the channel. So today we're going to be talking about part two of how to build our basic standard library. But before we get to that, I've been trying to do a lot of things with Sharp, and currently, personally, I'm trying to build a drone project using the actual programming language. However, because I don't have a JIT and because the language isn't technically fully optimized, it's not very quick. So I've been trying to send like information to a microchip and it takes about 1 millisecond, which is too slow. So yeah, but as with most things, if it tends to benefit me and I try to implement something, it's also going to benefit the channel. So I don't want to say too much about it. I mean, it's a pretty big announcement, but I'm sure you can kind of already get where I'm going here. I am trying to add some really cool stuff to the language where I can basically interface my language with C++. Now, my goal with this is not to just build a JNI like Java, like a Java native interface. I mean, I am going to have to do that, but I plan to basically make it better than Java because Java, in my opinion, to set up the JNI is a huge, huge pain in the ass. So, and I'm pretty sure lots of other developers can agree with me on that one. So, I have this quick little example here. We're not going to get into this code because it's really complicated, but my brain already hurts pretty badly. But we can see here if I do this, if I like make this a little short, I create a foo function and I load the library of foo test lib. Now that is going to be a DLL that's down here, and I'm going to have a foo of 105. So I'm going to pass 105 to this function, and the way you implement it is a lot simpler than on a lot of other languages. But basically, you're going to have to import what's called the SNB, or that's short for, what is it, Sharp Native Bridge. So it's my own kind of version of the JNI, and you're going to import that file, and it's going to have a ton of stuff in there that you're going to use. But basically you want to create a scope, and it's basically just like programming on Sharp but at C++ level. So obviously we're in the now I this is kind of busted. This isn't really correct. It's supposed to be app, so if I say scope of app, it's not going to work because I'm doing some stuff in the background, but basically this represents the module that you're in. Now, if we were inside of a class, so if this foo was inside of a class of, I don't know, house, why do I always use that one? So if we have house, and then we would basically do, and I know I'm getting off topic, but I think this is like really awesome. I was like jumping out of my chair this morning. So if I say HOUSE, then basically we're creating a scope that's inside of the app module and inside of the house class. So there's that. Also, I know like I tried some other stuff where if I create a scope and I could create a scope of, I don't know, let's say a different module, STD, and then I put some code in there. So let's say I put some code in there, and why is it complaining? Oh, because I don't have a comma. So if I put some code in the std module, well, let's say I have like a void work function that does some other stuff. If I try to directly call this work function, it's not really going to be able to resolve it. Oh, yes, it is. If I put this in the app in a different module, now it can't resolve work. You just do it like this, import, and you import the std module, and that imports this function, and you can call it. It's freaking awesome, guys. And it actually works. Like I can run it again. I'm basically saying number is 105, and I'm passing in the var from the high level to the low level, and I just say number.value, and I can also set the value to something else, and it just works flawlessly. So really proud about that, but that's going to be a feature long down the line. Before we get into the actual standard library stuff, and I will put so if you guys want to skip over this part, you totally can. I'll put a timestamp in the description below, but let's just see how to quickly implement the native keyword and the native functionality in the compiler. This is going to take like 2 minutes. It's very easy, so if you want to stick around, you can watch, see how I do it. So basically we want to do a couple things. So first, obviously, we want to go to our front end, and we want to go to our parser again. And we want to just add this value. So first we want to add this to the isAccess declaration. This is going to be the check where we call to see whether or not we're actually processing an access declaration before we do things like create classes and fields. You also want to add this code to this function here, the is keyword function, because obviously it's a new keyword. Also, by the way, I saw somebody left a comment about me not having syntax highlighting and having that be an idea. That's going to be a video for Wednesday. I actually had a plan to do that. As you can see, I do already have syntax highlighting, so I've already implemented it, but we'll go over that on Wednesday. And yeah, so let me go back here. So we have our key. So once we do that, all we have to do, that's it. So that's all we have to do on the parser side. And then on the compiler side, we have to add a access flag. So we have to add this to the access flags enum, and I just added it to the end of there. And here I'm going to copy this because I need to find it. And this has a value of what is that, 0x200. So that is this, right? So before, the max value of a bit for my access flag was 0x100. So I just made it after that. Obviously, we can go up to 32 because we support 32 bits in our programming language. So we've got plenty of space. But once we do that, finally, we need to go to our compiler and add it to a function. If I do a word search, you can see here we need to just add it to the parse method access flags. And when we're parsing it, all we need to do is just check to see if the flag.last is not equal to native and the flags.last, or the last flag that we're processing, is greater than static. Then we want to say here's an erroneous flag, and we want to go to that error. The reason why is because I believe in access flag you can't have any of these because these are for classes only. So if you have stable, unstable, or extension, or undefined, because we didn't process it properly, then obviously that's going to be an issue. And then these are the last things you got to do. So all you got to do is just add. So I increased the count, or the maximum amount of flags that a method can process. Before it was 2, now it's 3, because obviously we have one more. So we have the case where we have local, the flow is going to be local, static, and then native. So, and it's going to be less than or equal to, because remember, you can't have a public local. That doesn't make any sense. So it's either going to be public or private or protected or local, static, and then native. So that's how it's going to work. And then for static, again, it's just static native. So I added a check to see if we have 2 flags, then make sure it's a native. Otherwise, it's something wrong with that. Otherwise, if it's greater than 2, then I error out. And then finally, at the very end, I have a flag to check to see if the current flag is equal to native. And if the size of the flags are greater than 2, then I just do this code here. And that's it. It was pretty surprising how easy it was to implement this on the actual compiler side. So that was really surprising. But let's get into the video that we're supposed to be talking about today. So we're going to start going over the rest of the standard library. Now this is going to be more of an advanced video. I'm not really going to be going into all of the code, but I will just kind of talk high level about how to build a standard library. Honestly, if I went through all the code, I think the video would be too long. If any of you guys have any specific questions about how I came to the conclusion for any of the code that I have as we're going through it, you can always put that in the comment section below. And of course, I'll be happy to answer it, or you can always send me an email at devcode.channel. That's in the description as well. So let's just get into the first couple of things. So I'm not going to do this in any order. This is going to be completely random. So we're just going to kind of go through everything. So first you want to create a time class. This is going to be a way for us to do things with time, obviously, in our programming language. So this is going to kind of be an homage to the system.currentTime in mils, if any of you guys have ever programmed in Java. But yeah, so we're going to have a nanotime function, which is going to be in reference to some code here that is at the low level that basically gets the current time in, what is it, microseconds, or it was in nanoseconds since 1970 of January 1st. And then we'll have some conversion functions here to convert nano to micro, nano to mils, nano to seconds, and the current mils time, which is just like Java's system.currentTime mils, and we just call this conversion function here. We also want to do stuff with like sleeping threads, some cool stuff there. You also want to, do some stuff with waiting. So there's a difference between wait and sleep. When you guys are programming your programming language and you're building your multi-threading system, you want to add this code in. Now I'm being a little bit more verbose here because there's some important stuff, but when you have a programming language and you call the sleep function, there's a difference between sleeping and waiting in my language. And I think Java does this as well. But basically, once you sleep a thread, you can't wake it up until that thread has been, once the sleep is over with. So if you're going to sleep for 10 seconds, there's nothing you can do. You can't kill the thread, you can't interrupt the thread, you can't do anything because obviously the thread is blocked because it's sleeping. But if you use the wait command, you can interrupt the thread, you can kill it, you can pause the thread, which is called suspension in my programming language. That's what Android does. Whenever you have an application, your app gets suspended and it suspends all of its threads. We'll go over that stuff later. But yeah, so just keep that in mind, and hopefully you guys can add that function. And you also want to be able to have functions for, like, so here's a cool one, right? For measuring, time measurement. So if you want to test how long a piece of code is running, I have this measure function, and you pass in a time unit, which is down here, which is seconds, milliseconds, micro, nano, and you can time it up to nanoseconds because obviously we have that nano time function way at the top. So in here, I have my time unit and then I have my block that you pass in. We just want to basically check the time unit, and depending on which one, we want to do the appropriate conversion. And yeah, so that's how we do that. So that's also really nice. Now we're going to start getting into lists. When you start getting a little bit more high level with your language, you want to create list classes. Now, obviously, this is going to implement loopable. This is called a synced list. Synced list means that it is synchronized with each thread. So just like in Java, if you have the synchronized keyword, that's what that means. And basically it's thread safe. So whenever we call a function, like for instance, if we call get elements, we're going to lock the current instance of the actual list class, and then we're going to do whatever we need to do. And because of the technology I have in my compiler, once we return out of a scope that has a lock on an object, we always free up the lock before we return the scope. So it's 100% thread safe, and we don't have to worry about like not releasing the lock or anything. So there's tons of functions in here. I don't really have to go through all of them, but you want to just be able to have tons of utility functions to do various different things, like adding elements, indexing values, like getting the index of values, and you also want to have insertion functions and removing, and of course, you want to also be able to convert it to a string as well, and have some helper functions for index out of bounds. So you want to do that. You also want to create, let's see, what's the next one? Now, I have not yet gotten around to implementing dictionaries in my programming language. I've been doing tons of other things that, in my opinion, are pretty important. And I have a little bit of time before I have to actually implement this because by the time we get around to this code, it's going to be a long ways away. So that's another reason why I'm delaying it. But yes, you want to be able to create, some type of dictionary class. And to be honest, dictionaries are going to be exactly the same as like the list class. You're just going to have a bunch of lists of items and you're going to just do stuff on those items. So it's going to be relatively similar. And then of course you want to have the pair class to kind of coincide with the dictionary class. So that's pretty self-explanatory. You also want to have a list class. So this is going to be the non-thread safe version of the synced list class that we've seen before. Now, when you're creating this list class, you want to make sure that you have a linear allocation for this class. So what I mean by that is I did some calculations a while ago where I basically wanted to check to see how can I make this list class most efficient while also being very, performative and also not allocating so much information. Meaning that basically every time when you allocate this list is going to be pre-appending data. So like let's say we have a list of 10 items and let's say we add, that 10th item, the list is now going to allocate or reallocate so that the entire list size is now 20. And then once you get to 20, it's going to be 40, so on and so forth. You guys get the point. But you want to make sure that you have a great balance between the two. So a balance that I found was you want to take the size of the data or the size of the total list, and then you want to add that value to the size of the list, and you want to right shift it 4 bits. And then you also want to add the minimum capacity, which I believe is 128. Yeah. So what I found with this is I've actually kind of pulled some of this code from the Java source code as well, but Java kind of does this with array list where basically you want to just make sure as you're allocating it, like I think I did a test from 0 to 10 million. I think between that time I did a total of like 500 allocations or something like that. That's really good because if you allocate between 0 to 10 million, like 100,000 allocations, that's really going to slow your program down. So keep that in mind. You also want to create a hash table. I'm pretty sure you guys know what that is. It's basically just a way to hash various items. Of course, you can always go to all of my source code in my support 0.20 or 0.805, and you can just take a look at the code and kind of see what I did. It's all here in open source, so what you want to do is, of course, create all of your helper functions. Now, my hash table is very slim. I don't have a lot of code in here. I just have the basic stuff like adding elements, putting elements, which, what's the difference? I have no idea. I wrote this a while ago. Oh, that's at. That's not at. Yeah, so you want to be able to get elements at a certain key. You also want to be able to add elements by putting the values. And of course, I can't unfortunately use get or set because that's a keyword in my programming language. So that's why I had to use the at keyword. So just keep that in mind when you're like creating functions to still have decent names for them. You also want to have, removing of data, and that's it. I mean, mine's pretty sparse. And then I have like this entry class for holding information about each entry. Now, there's a difference between hash map and hash table that I didn't mention before. Hash table is thread safe. Now, this is exactly like Java. This is the way Java does it. So hash table is going to always, every time when you call a function inside of here, it's going to lock the instance of that hash table. Hash map is going to be the same exact code, like literally from resize to getting the value at a certain key to putting the value, it's 100% the same code. The only difference is one is thread safe and the other is not. So that's the difference between the two, if any of you guys are wondering. We also have, let's see, I know I have some reflect code in here. I have not gotten around to doing reflection in my language. I've constantly have fought with myself about doing this back and forth. So I don't honestly know if it's going to be done anytime soon. It's relatively easy for me to implement it. It's just how to implement it is the problem. So I'm going to skip over that. But let's see, did I go over everything inside of kernel? I believe so. Yeah. There's a util file. What does this do? Oh, okay. This is a util file for loading a library. And you also want to have that in the platform file, I think. Yeah, where I just load a library. We'll eventually get into code on how to access and manipulate DLLs and do the, JNI kind of like code that I showed you guys before. We'll get into that once I kind of finish it, but it's going to be a while before that gets done. So bear that in mind. Also, you want to create a math folder. And as you notice, like the way I do my folder structure in my modules, I don't remember if I mentioned this before, but I do it just like Java. For every folder, there's going to be a new module. So that's how I do it. But you want to create a basic math class or a basic math file where you just do a bunch of stuff. Like, so I do like sine, cosine, tangents, so, whatever, all this other stuff that I don't 100% know what all this does. I don't remember all the stuff I learned from high school and everything in math, but whatever. So you want to create all those various different math functions, and you want to create a basic. The way that I do it is, here's the kind of the challenge with doing this, right? You have all this code that you're going to be calling. So to make it a little bit more efficient, I just created two what I call master methods, and I pass in basic information, and I call a single system interrupt to then facilitate the transaction, I guess you could say, or the thing that I'm trying to do, and I pass it a proc or a procedure, and that then runs the procedure based on what function I have in here. So obviously you can see here I have square root. I pass a procedure of 0xe, I have pow, pass it the procedure of 0xd, and that code is located inside of my lib modules math folder, which is going to represent the C++ level of the math file. And as you can see, it's just a switch statement or a bunch of procedures, and it just calls the appropriate function. It's pretty straightforward. We'll get into how I make that connection from high level to low level, Now, I know you're probably wondering, wait, why am I talking about this code and how this works if I'm still working on making this work? Well, there's two different ways of how I connect with C++ at the low level. So there's one way where I call it a direct pipe. I'm just going to make up a name, where basically you have a fixed amount of instructions of things that you can do in C++. And the way that I do that is in my runtime, I have in my virtual machine, we'll go over this a little bit later, but I have a system interrupt function. And it's just literally a switch statement with a bunch of various different things that I need to do in the language for, like, here, there's actually a file for it. So it's called an interrupt flag. And I do a ton of different things. I mean, I delete files, create files, random number processing, suspending threads, tons of crap. As you can see, it's very big. But this is a fixed amount of code or fixed amount of things that I can do with the actual language. What makes the new code that I'm actually showing you guys, or I'm going to be showing you later, so amazing is that this is completely dynamic. So I can just define a native function at the high level and then make this binding to a C++ dynamically, because once my virtual machine is compiled, I can't change this. I can't change the amount of code that is inside of the switch statement. So it's very limited. So that's kind of why that's another reason why I'm adding this feature. But yeah, so that's kind of how all that stuff works. And let's see, so let me go back to my standard library support, so at 8205. You also want to, finally, we're going to start talking about my multi-threading system. Now, I have two main ways of how I do things in my multi-threading system. The first way is, well, first, before we get to that, let's talk about file system first. So I created a basic file system class. And what this does is you want to have a basic file system class that has various functions that are what I call, well, I'm actually not making up this word. It has to be operating system independent. So I have stuff like path separator, which, as you can see, for Linux is one thing, for Windows it's another. I have a normalize function resolving, and I have a ton of functions where they have to be implemented on the respective class that is being created. As you can see here, I have two files, Unix fs, winfs. So I use kind of like a, what is it called? A singleton design pattern to basically create these two different classes that are operating system independent, and they just kind of work. So we'll see how I do that in a little bit, but yeah, so you want to have just tons of various different functions for creating files, checking file permissions, modifying files, getting like a total list of, all the files that are inside of a folder. I mean, there's tons of stuff here that I can go through. I mean, this file is pretty huge. My file system is pretty in-depth. I actually spent a lot of time on this. And this is, again, based off of Java's file system. But I kind of always sprinkle my own little goodies on top to kind of make it a little bit of my own thing. I don't like to just copy 100% of what someone else is doing. So here's how I kind of do the WinFS and the LinuxFS. So actually here, I'm going to go to the file part. So I create a fs variable, a static variable, and again, this is a singleton pattern, and then I call the get file system function. What that's going to do is that's going to return a file system. Now, based on how my memory works in my programming language and how delegates work, it works perfectly. So I basically create a WinFS or a UnixFS based on whether or not we are Windows or Linux, and that, of course, is a bigger object, so you can, of course, shrink it down to the lesser or the smaller version of the object, which is the file system that they both inherit. If I go to the Win file system, as you can see, it inherits a base of file system. I have the slash or the path separator here, and then I have like a way to normalize paths. You want to do this because, like, if they pass in some garbage, like if they're in the incorrect direction, like they're this, where it's the Linux version, we want to correct that and make it the Windows version of path separators. Also, it just looks better when you actually look at the code. And as you can see here, I'm basically just implementing all of the functions that were supposed to be implemented in the FS or the file system code. So if I scroll back up to the top, there is a get attributes function, there's a check access function, and if I go back to the Win file system, you can see here I have those get attributes function and check access, and I have others as well. But I'm just trying to show you guys the basic concept of how I set up all this code to work together. I did that. I also have in my file, I guess that was kind of hard to say. I have a bunch of stuff like having path. So what path are we at? What's the path separator? Again, this calls the delegate, which returns a dynamic value based on what operating system we're currently on. And then I have some constructors here, a way to get the actual name, which this actually gets the name of the file, excluding the previous folders preceding it. So I just do that until I get to the separator, and then I return a substring of that value. And I don't really have to go through all this, but you guys can kind of see I have tons of stuff checking for if the file is writable, readable, if it's a directory, if it's a file hidden, tons of amazing things that you definitely need to do to make all of this stuff work. So I definitely recommend checking out this file. It's a very big one. So do that. Also, you want to create a critical section. Now, you're going to want to create this before you start to get into your threading system. This is basically a way for us to have critical sections of code, and the idea is that there's supposed to be things that we want to do that we don't really care about the instance that we're holding, basically. So when we call into this function, we just want to say, I want to run some code that's going to be thread safe, but I don't really care what object it's going to lock onto. So we have this global lock here, which it locks onto this object. And here, let me make this private. So if I make this private, that way you can't access it outside of this module. We just basically create a lock. Now, the reason why I don't use the lock high level keyword is because it just doesn't work well with the way I'm trying to do it. Basically, I have a try catch statement, and in there, I want to lock the object, the global lock, run the block. But the problem is that if there's an exception with this block, I always know that finally blocks are always going to execute. The issue is that if I wrap this entire code inside of a lock, it's not going to release this global lock because that's how the code works. So in the finally, because I know regardless of what happens, it's always going to execute, I release the lock by putting some assembly code in here to do that. Also, I have a way to do a critical section for passing in the actual lock value. And as you can see, I also do the assembly code here as well. So there's that. You also want to, let's see, is there anything else? No. Okay, so my threading system is really complicated. The way that I have my threading system built is I have a thread class, which now, although I've taken stuff from Android, I've taken stuff from Java, as well as I think some stuff from Kotlin as well for how my threading system works. At the high level, it's pretty different than how other languages do theirs. It's just how I've built my system. So I have various different constructors here that you can do different things like passing in the name of the thread, what's your main function, the stack size of that thread, and just a bunch of other stuff. I have, of course, a way to start threads. Now you can start it by passing args, or you can start it without passing args, so you just pass null. You can suspend threads, you can notify threads. Basically, once a thread is suspended, you can notify it by waking it up, which is another word for saying unsuspend the thread, as you can see. And you want to have all your basic stuff like joining threads, interrupting them, sleeping. Now, the way my language is going to work, and we're going to see this later on, every threading system is different depending on the platform it's running on. The way mines work is it's kind of similar to Python, where in Java, if you interrupt a thread, you have a way to catch that interrupt signal. In my programming language, once you interrupt it, it's dead. You kill it instantly. Python also does this as well. If you interrupt a thread, it just dies instantaneously. So just keep that in mind when you're writing your threading system. You want to kind of think of how everything's going to kind of work. But you also have like, waiting, which as you saw was the function that was in our time system or our time code. Now, it's really complicated to synchronize the high level code with the low level code. So the way that I do mines is, because I know some of you are probably thinking, well, okay, you create this thread. How do you know if the thread has been suspended and all of this stuff is like, obviously I have like these variables down here, right? I have in their state variables. So whether the thread is started, suspended, whether it's terminated, whether the thread is exited, all that stuff. How do you synchronize that with the low level version? If I go to my thread file in my runtime or my virtual machine. I have in here, as you can see, whether or not it's terminated, whether or not it's exited, the stack size, the same stuff that we have at the high level. The way that I do that is I do a pseudo way of doing it. So am I in the thread? Yeah. So the way I do it is I have, like, for instance, where's a good example? So like if you wait a thread, I get the current thread and I say it's suspended before I call the function. So that way at the high level, I know that it's going to set this value suspended to true at the low level. So where's that at? Yes. So it's going to set it to true at the low level. So I just match whatever it's going to do, basically. So that's how I'm going to do it. Of course, we also have exit, which just kills the thread. It just calls halt. Now I do a thing that's called exit thread. Now that is going to be inside. So we've kind of gone over all of the various things for the thread. So now we're going to kind of go into how it actually works at the low level. So I have what's called a kernel, and the kernel represents the base level way of how I do things. And now before we get into the kernel, there's also, where's that at? There is a platform, where is it? Kernel VM. This is how I kind of do a lot of the low level stuff. So whenever we suspend a thread, or let's see, no, that's not a good example. Whenever we exit a thread, I have all these local variables that I need to set before we actually exit the thread. So the thread exited, I need to set that to a value, whether or not we started it, the exit code of that thread, as you see here, and the native handle of that thread. The native handle represents basically what the native version of that is at the low level. We'll get into that later, but it's just a pointer to the actual thread at the virtual machine level. So you want to create a VM class, like I mentioned before, and it's going to do a lot of this low-level stuff for us, and you want to kind of centralize it in one place. So that way, at the high level, or as we get more high level in our code, you only have to worry about all those low-level things that it's doing. And then I call halt, which kills the current thread. It doesn't halt the virtual machine. It just kills the current thread that we're executing. So let's see, what else can I show? So I also created a thread group. This is just a way for us to hold multiple threads and do stuff on them. It's incomplete. It's still not finished yet. I mean, the code works. I've tested it, but I just need to add some more stuff like suspending all of the threads, waiting for all the threads inside of this thread group to finish, and just other cool stuff. Now I have a thread kernel. Now the thread kernel basically represents the starting point of each thread. So I have a thread result, which this represents all of the potential results that I can receive from trying to do something on a thread. So if I'm trying to illegally do something, a thread can have an invalid stack size, because if you set a stack size of 2, that obviously doesn't make sense. I have a minimum stack size, I believe, at the low level. So that prevents the user from setting it to 2 bytes or something crazy. Also, I have other stuff like illegally trying to join a thread that's died, and just other various things. But in our thread start, you want to get the current thread, and we want to basically set it up by setting up our local variables or our variables inside of that thread object, initialize the TLS system, and now I have some really cool stuff. This is also something similar that Java does, where I basically have an exception handler. So what you can do is at the high level, you can set what's called a exception handler. And what this does is if you have some code in your thread that you're running and you don't catch that exception, and right before it exits that thread and you get an uncaught exception, whatever error, you can catch that, or you can have a function that catches that uncaught exception, and you basically just do something instead of actually erroring out. Of course, the thread is still going to have to exit because we've backtracked all the way out to this piece of code. But as you can see, it's just a interface where it's a uncaught exception, and you pass it a throwable, which is just whatever the exception is, and you can cast it to whatever you want. That's why I have this base level throwable, so people can cast whatever object they have. And yeah, so there's that. What else? Is that everything before we do? There's different thread priorities. So of course you have minimum, normal, and max. And then finally, let's look at my task scheduling system. This thing is very complex, but let's just quickly go through it. So I have a task scheduling system, And this is a what I call a lightweight threading system. It's not intended to replace the multi-threading system. It's intended to be an aid to the multi-threading system. This is not like coroutines like in Kotlin or any other type of specific multi-threading platform. This is my own thing that I created. 100% of this code is completely made up. Like I didn't use any code from anything. I just, from my own knowledge, made this API. So the way it works is you have a task class and you can have various different things. You can time out various different tasks. You can schedule them for a future date by, I think it's in milliseconds or something. I don't remember. But you can do that. You can also set the name of the job. You can say how many times you want to repeat the job. You can pass args to it because obviously the job's going to be running on a separate thread. That's the idea. So you have to pass args this way. After that, we have a block, which basically blocks the calling thread. So whatever thread that is creating that job, if you want to block that calling thread until that job finishes, you can do that. You can set it as a long term, which just uses a different thread pool. I have two main thread pools, which have two different priorities. I think long term has a low priority and short term has a max priority. Obviously, that makes sense because long term threads are expected to run more long term. So that's why I kind of did that. And then you also have a builder. The job builder is basically going to be a way for us to build a job. So we can set various different things on that job, like all those things that we saw previously. They're basically what I call settings for a single job. And you can basically do all of that. And once you do that, you can assign the job a block of code. So what we're going to do is we're going to have, now there's only one way to do this. We can assign it by passing this block here, and that basically just sets the main function to the scheduled job. So the scheduled job is down here. We'll go into that class in a second. This calls an operator overload to set the main function. We also have other ways to set like what I call deferred jobs. So if we go to my, what is this, my repository here, we can see that I have an example where we create a deferred task. And basically, a deferred task is basically a way for us to run some code and then wait for the response later on. So you just create a deferred task of int, because I guess in this example we return an integer, and you have this function of lots of math. You can time out the job if it takes too long, but in this example it's not really going to work that way. But we simulate doing lots of math. It takes a second, so it's before the timeout, and we basically pass in the observer, which represents the thing that is observing the job. And with that observer, we can post some data to it. Now, if any of you guys have developed on Android, this is kind of similar to live data, where you basically have a piece of information that you'd like to observe. And whenever there's information that's sent to that object, then you receive a notification, and I'm doing the finger bunny ear things, quote unquote notifications, and you can respond to it accordingly. But if you don't do that, you can also just get the response. So what this is a single fire listening event. Basically, you observe this deferred task one time. Once you get the result or the response, you get the response returned to you, and yeah, that's how that works. I feel like I'm talking too much, but yeah. So let's see. So we went over task. Here's the observable class. It's just a really nice way to observe data. So you can post data as we saw, and we set the change value, and we notify all of our observers, and we set change to false. And here's the data that's going to hold the actual data that we're observing. And once you observe, you pass a block of an observable and of type whatever, and then you basically set the update function, which is going to be here, and then you just add that observable. So once we notify or get our notification as a result of posting data to the observable, then we basically call every single update function inside of our observers list. And if we get any errors, like a cancellation exception or just a generic error, then we remove that observable from the list. And we also have, let's see, so let's look at job. So job is basically a way for us to create a job, and we can either execute it asynchronously or synchronously, meaning on the calling thread. That's how we block the thread, because effectively we just execute that code on the calling thread. when we execute async, the way it works, I don't want to get into it too much, but we basically use our system of suspending and unsuspending threads to notify certain threads of data being there. And we use what's called a controller to set the current job that we're needing to execute. And basically what happens is down here we have a job main, which represents the main function of every time we want to execute a job. We get our controller and we set our controller's value. Where's that at? That is a job controller. So we set the scheduled job or the job that we need to execute to the instance of the thing we need to execute, and we just basically run it. And once we're done, we set that job to null and we wait for another notification or until the thread is unsuspended due to there being another job present. So I have a bunch of code in here to do all of that. And then I have what's called a job scheduler. Really cool. Basically what this does is it allows us to schedule jobs, obviously. I have a max thread function which figures out how many threads can we allocate to each thread pool, whether it be short term or long term. And then I have a scheduler main, which is the main function of the job scheduler. And I do a bunch of checks to see if we need to kill the thread because it's timed out, or whether or not we need to start the thread because it's being delayed sometime in the future, and a bunch of other stuff. And also have ways to, pick a host or pick the thread that the job is supposed to run on. And then we have a execute synchronous. Finally, we have a deferred task, which allows us to basically execute tasks and get the value at a later date. So we just create a bunch of functions for that. And yeah, so let's kind of look to see how this code works. And let's kind of go through the piping one time so we can kind of tie all this together. So let's say we create a launch. We launch, and all this code again works, by the way. So if you guys want to test it out, you can of course do that. But let's say we launch a value and we're going to run some code in here. What that's going to do is that's going to call the task function, and that's going to, or not that, not the task function, that's going to call this launcher function of a job master. And we actually didn't go over the job master, but that is just a way for us to facilitate creation and starting of jobs. And the job master is used by the job scheduler to do all of that stuff. But yeah, so in there we call this function. So that is basically an empty block. So we call this function here, this operator overload. We create a job and we set the main based on the block here, and we start that job, which call this function. We check to see if we have started our scheduler, because I don't want, like, if someone doesn't want to use this API, I don't want to have this scheduler just running in the background, wasting CPU space if there's never going to be a job to execute. So the scheduler will only start if the user decides to use this API. And start scheduler basically just creates a new thread and call it task scheduler, and then it puts it in the long-term pool and it just starts it with no values. Once we do that, then we set our, I don't know what the hell that does, um, but we set a delay time for something, and then we basically, if we block a caller, like if we have that block function that we saw before, we just execute synchronously, meaning execute it on the actual thread that's calling it. And I have no idea where that code is actually defined. Is that in the, it doesn't matter. But we basically just execute the block of main that we passed in here, or passed in above here. Otherwise, we add the job to the job queue. Now this job queue is going to be a synced list, so it's thread safe, and that way if multiple threads are creating jobs, it works fine. And basically the job scheduler is then going to pick up that job every time it does its loop. So it's going to check to see if there are no jobs, it yields, and it sleeps for 5 milliseconds. Otherwise, if there's a job, then it does some stuff to figure it out. And it decides whether or not it's time to run it based on if the job has a host from this getHost function. And that's what we do. So we call execute job eventually once all of this magical code runs to figure out what to do or when to run the job. We get the host, we set the host of that job, we set the controller equal to getting the host controller. So we basically just have a list of controllers and we set the controller based on what thread it's attached to. And then we execute async, which we already saw that is in the job function. We call execute async, and we just either, if the host is active, meaning the thread is waiting for a notification, we notify that host. Otherwise, we start the thread and we pass in the controller. which then calls this function of job main, which does all this stuff, and that's it. So I hope you guys enjoyed the video. I know that was a lot. If you have any questions, definitely write them in the comment section below. I know this was a ton of information. But yeah, of course, also if you guys would love to help support the channel, you can always head over to the GitHub repository at andrewdevcd/sharp. When you do, definitely watch, start, and fork this repository. That gives this language a lot more visibility and let other developers know this language exists. Also, if you guys are curious about some of the stuff that I do on a daily basis, you can always head over to the remastered branch. And I write some pretty decent commits, so you can kind of get a gist of what I've been up to without really having to look too much in the code. Also, if you guys are curious about some of the things that I've done in the past to the language or stuff that I'm looking to add in the future, you can head over to the docs folder, and there's two main files. There's the changelist file, which has recently been updated with the version 0.2.805. That contains all of the code that I've done in the past, and the roadmap file contains all that information as well as new stuff that I'm looking to add in the future. So hope you guys enjoyed the video. As usual, if you're new to the channel, definitely consider subscribing, and until next time, I'll see you guys later.